This is going to be review number 2, and we're going to take a look at factoring. So today we're going to define what factoring means. We're going to factor a quadratic equation, and then we're also going to look at the zero product property. So when we factor, let's first understand what that means. So a factor is part of multiplication. So in this instance here, it says 2 times 3 equals 6. The 2 and the 3 are factors. So when you are asked to factor something, that means you need to take the statement and you need to express it as multiplication. So in this next piece right here, it says completely factor 60. We call that the prime factorization. That means you have to completely break down 60 into various forms of multiplication. That's 2 and 5. So 60 is the same as 2 times 2 times 3 times 5. So now that we know what a factor is, now let's look at the different types of factoring once we look at more abstract numbers. So for example, the next is going to be the greatest common factor. And all that is within a statement, we look at every single factor or every single value that's in common. Now, a way to think about it is it's almost like reverse distributing. So in this instance here, right, if I distribute that, that gives me 12x squared and then plus 24x. Well, I could also factor the 6x out of this, right? There's a 6x, there's a 6x, and if I factor out that 6x, then I'm left originally with the 2x plus 4. And so what we're doing is we're looking at factors that's in common with every single term. Now, this 6x is actually not the greatest common factor. The greatest common factor, well, what's the highest value that's divisible into 12 and 24? That's 12. What's the highest value divisible in x squared and x is going to be x. And so if I do that, now I'm going to be left with x. And then here I'm going to be left with plus 2. And so that is actually completely factoring using the greatest common factor. Now if I distribute this, I should get back to this original value. So let's factor this. The first thing that we're always going to check when we factor is going to be the greatest common factor. We always check for the greatest common factor. So when there's a negative in front, we factor out that negative. So that's going to be the first thing that I'm going to take out. Then between a 12, a 4, and a 2, there's a 2 in common. That's the highest number, basically divisible in all of them. And then the next is going to be an x. So if I factored out that minus 2x, it's almost as if you're dividing every single term by that minus 2x, and then you can write whatever you get left in there. So negative 12 over negative 2 is 6. X cubed over x is x squared. This is going to be plus 2. And then here minus the 2's, and I get x to the third. Now you can check yourself, because if you multiply this back through, you should get that original statement. But this right here is the greatest common factor. Next one. So between, there's a negative in front, so I'm going to factor out that negative. So between 72, 63, and 72, there is a 9. And then the highest x is going to be x to the third. So divide that by a negative, so it becomes positive. 72 and 9 is 8. And then take out 3 of those x's, so I'm only left with x squared. Remember, we're almost dividing everything by that. And then dividing 63 by 9, that's a negative 9, that gives me a negative 7. And then I'm taking out 3 x's, so there's 1 left. And then divide the negative x, or the negative 9 into the 72. You're going to get minus 8, x cubed and x cubed, right? They're going to cancel out, and so I'm left with that. So this is factoring, GCF. This right here is that greatest common factor. Now you're probably thinking, you're like, wait a minute, Mr. Duval. You just said, when we factor, we're writing it as multiplication. Well, we did. This is negative 9 times x cubed times and then it's all of this. Times. We have written it like multiplication. Those are minuses. But we took this expression, which is adding and subtracting, and we expressed it as multiplication. That is factoring. So now let's look at factor by grouping. Now typically we have factor by grouping when there's 4 terms. And so the reason why we call it grouping is because what we're going to do is we're going to group our terms. And so we look at each side. We look at this side here, and we look at this side here. So we first start with this side, and we do the greatest common factor. So 6 and 5, there's nothing in common, but x cubed and x squared, there's an x squared in common, and so you're going to be left with 6x plus 5. Now there's a negative in common, so we factor out the negative, and that's it. Now remember, if we distribute that, I should get that up there. So that's how we can kind of check it. Now when we do factor by grouping, the cool thing about this is these values right here should be the same. That means we did it right. So now what's in common between this statement and this statement? Well, it's what's highlighted. So we're going to factor that out. So we have a 6x plus 5. Now what's left is what's going to be in front here. So I'll change the color. So I have the x squared, and then that's a minus 1. So I have x squared minus 1. Now an easier way to just remember it, when we do factor by grouping, just rewrite what's in common, bam. What's in front, this and this, bam. You put that in the other parenthesis. Let's look at another one. So 4 terms, my brain should be thinking factor by grouping. So what's in common between 2n cubed and then minus n squared? So there's an n squared in common. And so I'm going to have 2n minus 1. And then between the minus 8n and the minus 4, well, there's a negative. And then between 8 and 4 is 4. I'm going to have a 2n plus 1. So there's a typo. This should be a plus in the problem. So then if that's a plus, then that needs to be a minus. So it's just a typo in the problem. So now what's in common here? So 2n minus 1. What's in front? N squared minus 4. That's my answer. Now technically this factors further, but we're not doing that just yet. So we're not worrying about that too much yet. Let's look at one more. So between 5n cubed and 10m squared, there's a 5 in common and an m squared. And so what's going to be left is m plus 2. And then between here is nothing, so plus 1. So I have my m plus 2. And so whatever's the same, put that in one parenthesis. Whatever's in front, so I have a 5m squared and then the plus 1. And that's my answer. Now we're going to move on to factoring a trinomial. And with factoring a trinomial, there's just a slight difference. Now, you guys have learned this Xbox method. A times C goes up, B goes on the bottom, and then you put the factors of those numbers here, and then there's all these other special tricks that you do. If you 100% understand it and can 100% get it right every single time, then this part is not for you. If at all you were like, ugh, this Xbox method is annoying. Ugh, I don't like the Xbox method. It gets so confusing, or I don't remember it, or any of those things, right? If you do not remember this, this is for you. This is going to help you. Now, there is something that is correct about the Xbox method, and it's these 2 elements. So we're still going to do that. We're still going to multiply A times C together. A times C. So 2 times 9, 18. I still want to find the factors that are going to add to B. So I want to add to negative 9. So I'm going to go through the factors. 1 and 18, 2 and 9, 3 and 6. Well, to get a negative 9, I need a minus 3 and a minus 6. That's all the same. Now this is where it turns into something slightly different, and this is why I think it's actually a little bit better. What we're going to do is we're going to rewrite this minus 9a. We're going to rewrite this from this. So those two things are going to correspond to each other. So instead of writing minus 9a, I'm going to write minus 3a minus 6a plus 9. Minus 3a and minus 6a equals negative 9. How did I know to break it into minus 3a and minus 6a? From this. So you just pretend like the variables are attached to that. Now the cool thing about this is there's 4 terms. Wait, what did we just learn and how we could factor with 4 terms? Factor by grouping. So what's in common here is a. 2a minus 3. What's in common here is going to be between 6 and 9 is a 3, and we have to factor out that negative. So it'd be negative 3, and then we get 2a minus 3. So whatever's the same, whatever's in front. Now the cool thing about this way of factoring is I didn't memorize any shortcuts. There was no special trick. There wasn't a, oh, well, because the value that's in front of the squared part is not 1, well, now I have to do this other special trick to make it factored. I didn't have to do any of that stuff, right? Every single time you multiply a times c. Every single time you're going to list the factors until you find the ones that add to b. Then you just rewrite it, and the rest is factored by grouping. Let's look at another one. A times c. So a times c. Factors that add to b. So you just list them. Nope. 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 4 doesn't work. Let's try 5. Hey, look at that. Negative 5 times negative 6 gives me a 30. Negative 5 plus negative 6 gives me negative 11. So we're going to break it apart. So that's negative 5n and negative 6n. So now factor by grouping. 5n. And then I'm going to be left with n minus 1. Because if you divide that by 5n, right, they cancel out and you're left with 1. And then there's that negative again, so I got to factor out the negative. And then there's a 6 in common, and so you get n minus 1. So now write whatever's the same, whatever's in front, put it in the other parenthesis. Now a common question that I have here is, well, what if I wrote negative 6n and then the minus 5? Does it matter which order that you do it? The answer is no. It would factor just the same. Otherwise. So what's in common? Just an n. The minus, and then that's it. So what's the same? 5n minus 6. Whatever's in front, n minus 1. Boom! They're the same. Look at that. So it does not matter which order you write it in. Let's look at one more. A times c. 9. Factors in 9. That add to 10. 1 and 9. Rewrite it. Factor by grouping. There's an r in common. There's a 9 in common. So whatever's the same and whatever's in front. I know, my R's kind of look like V's here. I apologize. It's kind of weird. This is the best R in the world, but the rest just, ugh. Ugh. All right, so now the last piece, the zero product principle. What the zero product principle states is if you have two factors, right? Factors, things being multiplied. If you have two things, A and B, being multiplied and it equals 0, we can make the assumption that either A is 0 or B is 0. We can make that assumption. So that means that if this something equals to 0, if I'm able to rewrite that as multiplication, then I can go through and I could use the zero product principle to solve. So we know how to factor a trinomial. We know how to express that as multiplication. So A times C, so -4. Factors of -4 that add to -3, so I have 1 and 4. So a +1 and a -4. So rewriting that. 1x, because that's the variable, minus 4x. Factor by grouping. There's an x in common. There's a -4 in common. So then I have x plus 1 and x minus 4. Okay, so I wrote it as multiplication. Now the zero product principle says that because this equals 0, I can assume that x plus 1 equals 0. So you can assume that factor equals 0. And you can assume that that factor equals 0. Now you're probably thinking like, why? Well, we're going to see in a second. So if I subtract 1, you solve for each, you get x equals -1. If I solve for each one, add 4, you get x equals 4. Now here's the reason why. If I take this 4 and I plug it in, I'm going to get 4 plus 1, which is 5, times 4 minus 4, which is 0. Well, 5 times 0 equals 0. It works. So the zero product principle, because it's multiplying it equals 0, I just need to know what makes this factor 0 and what makes this factor 0. I could have a bunch of factors. I could say, I could have an extra x plus 3 here, and then I would have 3 different values that I set equal to 0. It doesn't matter. When you're multiplying it equals 0, you can assume that each factor is 0. So next one, A times C. So this times this, -6. How do those add to B? So 1 and 6, 2 and 3. Ooh, look at this. Which one is it? Because I could do a +6 and a -1, or I could do a +2 and a +3. So remember, we have to get a -6 if I multiply. So the only way I'm getting a -6 is if it's those two. +2 times +3 does not give me 6. So 2x squared minus x plus 6x minus 3 equals 0. Factor by grouping. X times 2x minus 1. Factor by grouping here. We're going to get a 3 in common. So I get plus 3 times 2x minus 1. So whatever's the same, whatever's in front. So now I could set each one equal to 0. So add 1, divide by 2, you get x equals 1/2. Minus 3, you get x equals -3. So those are my values. So number 14, we're going to piece everything together. If you notice, there's something in common with everything first. Do that first. So factor out the 2. If you see something in common, do GCF. So then here, factoring this, factors of 8 that add to 9 is 1 and 8. So just kind of skipping that a little bit just to quickly go ahead. Wow, that kind of got carried away there. Setting each one equal to 0. Does 2 equal 0? Nah, that doesn't make any sense. X plus 8 equals 0, and x plus 1 equals 0. So I get x equals negative 8, and x equals negative 1. Now I want you guys to go ahead and try number 15. Remember, we start off with a times c. Okay, so going over it, if I did a times c, you should have 1 and 40. So it should be negative 1 and negative 40. What is going on with my pen? It's kind of going all over the place there. But so we get 5b squared minus 1 minus 40. This is b. And then plus 8. So factor by grouping. There's a b in common. Factor by grouping. There's a minus. And it looks like this is supposed to be an 8. Oh, that's a plus. Yeah, my pen is whacking out right now. So minus, and then there's an 8 in common. So minus 8. And then so that's going to be 5b minus 1 because I divided by negative. So negative is a positive. 40 over 8 is 5. B still there. Positive negative is a negative. 8 over 8 is 1. Okay, good. So now that's going to be 5b minus 1 times b minus 8. And then when you set those equal to 0, you should get b equals 1 over 5 and 8. So to conclude this lesson, what did we learn today? We learned how to factor. So what are some of those different ways that we factored? We did factor using the GCF. We did factor using by grouping. So it's factor by grouping. And then we did factoring a trinomial. So what should we check every single time we go through and factor? GCF. That should be the first thing you check every single time. This does conclude our lesson. If you have any other questions, please leave them in the comments.